Okay, good morning class.
Morning, sir.
So today we're looking at number patterns. This is from chapter 3. So if you want to go through these notes here, you'll find it in the description box below. Okay, so I'm just going to pause the video so that we don't have the video too long. Okay. Right, so let's go through, we went through those notes there. So we're looking at the example on page 57. The question says, write down the first 4 terms of the sequence Tn is equal to 2n plus 1. The first 4 terms. So when we start, we are given a general term. So if Tn is equal to 2n plus 1, then T1 is going to be 2 terms. Now in n's place, what do I have? A 1. So it's 1 plus 1, which is 2 plus 1, which is 3. Let's go for term 2. What is in n's place now? 2. So it's 2 times 2 plus 1, which is 5. Let's go with term 3. That's going to be 2 times 3 plus 1. 2 times 3 is 6 plus 1 is 7. T4, 2 times 4 plus 1, which is 9. Write down the first 4 terms, and these are the first 4 terms. Okay. If you want to be fancy, you can write 3, 5, 7, and 9. These are your first 4 terms. Yes. I know you guys don't want to do anything extra for no marks, no? You know already, no? Will any confusion? Is there any confusion so far? No. Let's look at the next one. The next example is also on page 59, correct? Is that bar? Yeah. Huh? 58. And this is 4. Exercise 3.1 on page 59. Here we are told, write the first 4 terms of the sequence. Write down the first 4 terms. Write down the first 4 terms. Anaya, what's your Anna, Ania? Ania. You know what's your Ania? No. No, why not taking note? But now you're losing this work also. So when are you going to do this work? Take note here, please, my daughter. So that you don't have to do it later. Okay, so here we are given a general term Tn is equal to 1 over n plus 1. Not so? Tn is equal to 1 over n plus 1. Okay, the first 4 terms, where do we start? Term 1. So T1 is equal to 1 over 1 plus 1. Remember, we replaced n now with a 1. So it's 1 over 2. Let's go with term 2. So 1 over 2 plus 1, which is 1 over 3. Term 3. 1 over 3 plus 1, which is 1 over 4. T4 is 1 over 4 plus 1, which is 5. You guys understand? So my first 4 terms is a half, a third, a quarter, a fifth. What if I ask you to extend this by another 2 terms, what will it be? 1 over 6, 1 over 7, yeah, and so on. You guys understand? So easy. Okay. Listen. You still think this stuff is difficult? Right, let's carry on. Let's see. I gave you this work because it's easy. But now you said you had issues, so let's try and sort it out. Okay. People, let's look at the next one. Write the first 4 terms of this sequence. Okay. If they're always going to give us a general term as it did in the first 2 examples, our lives are going to be boring. It's going to be nice. Oh, yeah. So they must spice it up first. Okay, it says write down the first 4 terms of the sequence. But hang on, we are told here that T1, let's make this a bit bigger. Bigger is better, no? To see. Okay. So here we are told that Tn plus 1 is equal to Tn plus n, and T1 is 4. Okay. So if you look at the first 4 terms, what's the first term? 4. They already gave us the first term. Now if you go, if n is 1, if n is equal to 1 for this formula here, then wherever I see a n, I put a 1. So you say, okay, T, what's 1 plus 1? 2. You guys are clever. Equals T1 plus 1. Not so. But, not O, T. T1 is what? 4. So that's going to give you 4 plus 1, which is 5. Okay, we'll do another one. Let's go. Tn is equal, what if n is 2? So it will be T, so whenever I see n, I put the 2. So it will be 2 plus 1 is 3 equals T2 plus 2. So hang on. T2 is 5. Yes. So 5 plus 2? 7. Okay, where's the time, please? It is equal to 3 now. So it's going to be T 4 equals T 3 plus 3. So T3 is what? 7 plus 3? 10. There's the first 3 terms of that sequence. First 4. Okay. People are going to do it so easy. And this is called the recursive formula. Okay. Right, let's carry on with our lives. Now to find it, to find term 3, we substitute. Oh, that's what they explained now. No. To find term 3, we substitute n is equal to 3 into the general formula. For the 100th term, we substitute n to be 100. Okay, you guys understand it? In example, Tn is equal to 2n plus 1, then T100 is equal to 2 times 100 plus 1, which is 201. In the other example, we had Tn is equal to 1 over n plus 1. T100 is going to be 1 over 100 plus 1, which is 101. However, in the one where we just did out the recursive formula, I need to know term 99. But for term 99, I needed to know term 98 and then 97. So for the recursive formula, the third example that we did, you won't be able to go straight into term 100. You guys understand? So will we ask you then to calculate term 100 in that case? No. You could be nice people, though, even though you don't see it like that. No? Be nice people. We try. You will just look at the example, and this example is on page, what's it, 58? Right. So we are given the sequence 1, 5, 9 and 13. So let's write the sequence here. 1, 5, 9 and 13. So let's go to the first question. We are told list the next 3 terms. The next 3 terms. This is the for on, for A. How do I move from 4 to 1 to 5?
Plus 4.
You add 4. And here, you will look here, my girl. Plus 4. Not so. So now I add 5, no?
No.
Why not? Follow the pattern. Okay? So again we add 4. And then again add 4. And then again 4. So 13 plus 4 is 17. Yes. 21. Yes. 25. So these are the next 3 terms of the sequence. Okay. You guys got it? Right. Don't lose it. No? Then you get B. Describe the pattern. So what would this be? With you we did this in grade 8, no? Start with the number 1. Then add 2 to every consecutive term. Did we do that in grade 8? No? Yes, we did it, yes. For those of you with me in grade 8, we did it. Okay. So, see what the textbook says. The textbook says, it's just different ways to express it, okay? Each term is 4 more than the previous term. Okay, but I don't think that is fair, because they would have to say where you must start. You must start somewhere. Because what if I say just add 4 to every previous term? What if I say I want to start at 6? Will it give me this pattern? No, because it will be 10, 14 and so on. However, if I say start with 1, which is normally the first term, and then add 4 to the previous. Okay. So if you start with 1, and if you add 4, of course you only get 5. And then if you're going to carry on with this here to the previous term, you're adding 4, then I'll get 9. And then that. So I think you would have to say where you're starting. Okay, I think that's fine. Let's look at C. Write down a formula for the general term. Now there's 2 ways of doing this, okay? I'll do both ways with you until you are comfortable with both. Or you choose one of the 2. And I will do the second way normally, okay? But Tn is a general term. Not so. What am I adding all the time? 4. So I put 4. For what? Okay. So we say, okay, for term 1, n must be 1. Not so. But what's 1 times 4? Is the first term 4? No. What must I do to 4 to get to 1? Minus 3. And there's the general term. And we test it. It's worth a test. What term is this? What term? Term 3. So you put waves here in a 3. So T3 is equal to 4 times 3 is 12 minus 9. Can you see it? What is? Right. Or you say Tn is equal to, whenever we're working out the general term of an arithmetic sequence here, what do we say? It's going to be A plus n minus 1 d. You'll see later on you're going to use this, is going to be easier. You just take an extra step, but here you don't have to think much, which you guys like, no? So we said Dn is equal to, people, A is your first, write this down, your first term of the sequence. Okay? Tn is your general term. D is your common difference. Let me see, common difference. A is your first term, and N is your term number or your position number. Position number in the sequence. Okay. So Tn is what, people? General term. A is your first term. D, common difference. And N, your position number in the sequence. Okay. So what is my first term in the sequence? 1. So I say 1 plus n minus 1 times, and what's your d? What am I adding all the time? 4. So if I was subtracting 4 all the time, I would have written here negative 4. Can you see that?
Yes.
So I would put negative 4. What do I do? This is a matter of simplifying. So 1, now negative 4 times n is negative 4n plus. No, why am I putting minus 4? Sorry, I put negative 4. So it's 1 plus n minus 1 times 4. I put negative 4 because I explained about the negative. Sorry about that. So to get rid of the brackets, multiply. So I get 1 plus 4n minus 4. Which gives us 4n minus 3. Same. Okay, you like the first one?
No.
You like the second one? You like no way? Or you like the second one? I also like the second one. So people, you can apply any method of the two. Okay? And you'll get the full model. Is all right, okay? Does work boring for you? No, you headache of this work? Always, so only now. Because of the maths. I think it's your friends. Your friends that give you a headache. Huh? You were right, am I right? Yes. Sadly, your friends don't do their work, no? Huh? People, for the sequence 2, 4, 6, 8, no, 2, 4, 8, 60. Hey, you're doubling. Huh? Who? Who's that? Hey. Put it back in there when she's done. I don't know if she's going to use both. Okay. Right. People, for the sequence 2, 4, 8, 60. Right, so hang on. If I got 2, 4, 8, 16. What is the next 3 terms? So I don't go from 1 to the next. Times by 2. Then? Times. Yes. The 32 big ones, yes, and then? 64 one, yes? 120. So easy. How is it then? How must I not feel? You're doubting me. Now tonight when I cry myself to sleep, then my wife doesn't know why. Huh? Now you doubting me. Now you see. But why would you say, sir, the textbook is wrong? You always think I'm wrong. You was? Okay, you was. Okay. Right, let's look at B. Describe the pattern. You start with 2. Then multiply each successive or previous term by. There we go. Okay. Now, what would the general term be? Write down a formula for the general term. Tn, yes, good start. Two to the power n. Wow. Good. Oh, it's in a book. Oh, I thought you got from your head. But listen, look at it this way. This is 2 to the 1, 2 to the 2, 2 to the 3, 2, 4, 2, 5, 2, 6, 2, 7. So this was term 1, term 2, term 3, term 4. So that would simply be Tn is equal to 2 to the n. Easy, no? What's so difficult about it, Michael? You say? What's so difficult about it? Sometimes I don't like teaching it because it's too easy. The children are going to take me serious when it comes to geometry and those things. No? It's too easy. People! Now this, you see the previous sum, we were adding or subtracting the same number all the time, no? Adding in particular. But this, we are actually multiplying. Now whenever we multiply, we can follow a formula. Tn is equal to A or n minus 1. Okay. Right, what does A stand for? First term. Or? Radius. Imagine. Okay, so your D was what here? Common difference. So remember, just add the D is going to be term 3 minus term 2 must be equal to T2 minus T1. Very important to understand. Because what is term 3 minus term 2 from here? 9 minus 5. Can you see that? And 9 minus 5 is 4. And what is 5 minus 1? 4. Can you see? Both is 4. So it's a common difference. Can you see? That's the condition it has to be met. However, for the common ratio, R is stand for common ratio. R is your common ratio. So Tn is still your general term, N is still your position number, and A is still your first term. So R is your common ratio. That one is a formula. R is equal to T3 over T2 is equal to T2 over T1. So let's check if it's correct, if it works. What is term 3 here? 8. 8 divided by 4? 2. So that is 2. What is 4 divided by 2? 2. So yes, it is a common ratio. Do you guys understand? Well, which part don't you understand? Just remember, if I'm multiplying by the same number all the time, it's a constant ratio. If I'm adding or subtracting by the same number all the time, it's a constant difference. Common difference. There's a D value. Okay? So what's your A value here, people, in your first term? 2 times, what's my R value? Also 2. Can you see that? So it will be 2 n minus 1. Now, in grade 9 we taught you bases are the same and then I multiply. What did I do to the exponents? You add it. So it's going to be 2 to the 1 plus n minus 1, which is 2 to the n. It's the same. Also, we would have left the answer like that, you would have gotten the full marks for it anyway. Okay, that and that is equivalent answers. Okay. Alright, let's carry on. Are we still on the same page? We are page 59 now. Okay. Okay. The sequence 1, 4, 9, 16. Are we in week 1 or week 2?
Week 1.
Okay. So the sequence 4, 1, 4, 9, 16. is 1, 4, 9, 16. Okay. So how do I move from one term to the next? 3. Then 5. Then 7. Then 9. Then 11. Then 13. So in other words, I'm adding 2 here all the time. Not so. So this is what we call our first difference. Okay, and this will of course be your second difference. So if the sum has, where the sequence has a second common difference, it will be a quadratic function. Okay, make a note there. If it has a second constant difference or common difference, it will be a quadratic function. Okay, or a quadratic sequence. Okay. Okay. So if it has a second constant difference, it will be quadratic. If it has a first constant difference, it's arithmetic. Okay? Or linear. Alright. So 16 plus 9 is 25, 36, 49. Square numbers. Okay. Let's look at B. Describe the pattern. So this would be your term number. Your term number squared. Not so. Or your position number squared. Let's see what the textbook says. This is a sequence of consecutive perfect squares. It's saying the same thing. Okay. You all agree with that?
Yes, sir.
See any confusion? For C, you want the general term. So what did we notice here? That was 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on and so on. So the general term would simply be n squared. Tn is equal to n squared. So they could ask you, what is the value of T10? Should it be? Which is 100. And so on and so on. You guys understand? They ask you which term is equal to which position would term 2 to 5 be?
25.
Why? Because they're going to be in switch for the 25 and 2 to 5. It's going to give you 15. So therefore term 15 is equal to 2 to 5. People, you guys understand? Easy. Okay. I'm still trying to get to the difficult part you guys was talking about. Alright, so that basically brings us to the end of the examples for exercise 3.1. Now I would like you guys to do the whole of exercise 3.1. The whole one. But you must add problems with it. Right. Now your problem should be sorted. Now you try the sums that you couldn't have done. If you still have a problem, you come to me, okay?